the diagram, right? And try to apply the principle of movement. What's the rule again? Clockwise equal to anti-clockwise, right? So clockwise equals to anti-clockwise. Set up there for me, please, and then what are we going into today is the fast people, right? I don't make it up, say my fraction. What's one? I give my whole numbers there, my guy. Fraction. Well, then I'm waiting. What are we? Billion, right? Billion. Right, let's go now. All right, let's go, right? So in order for us to work this out, right, the system has to be in equilibrium. So therefore, anti-clockwise moments is equal to clockwise moments, right? So which ones are anti-clockwise, anti-clockwise, anti-clockwise? Remember how to figure it out? One on the pivot, one on the force, right? The one on the force turn in the direction of the force. That's okay? I think you've all have heard for a while. Do I have one for this? Actually, yes. All right, so clockwise will be x by 4, because it's 4 meters away. 8 by 1, 8 by 1 meter from the pivot. And then 15 by 3. So this will be 4x plus 8 is equal to 45. Move across the 8. So you will get 4x is equal to, how much is that? 37. So x is equal to 37 divided by 4. Right? How much you got there? 9.25 or something? Are you okay with that? But the problem with these questions is that they don't come this straightforward. So now we're going to take a look at the past papers where they apply them to a real life situation. My advice here is take the diagram that they gave you and try to make it look like this. Okay? So let's go. Let's try one. Oh wait, this thing was moved again. What happens? Save it. Hold on, yeah. Right, let's start easy, then we'll go a little bit harder, right? Right, the first part is just definition, right? So I'm going straight to the calculation part. Hold on, huh? Then you can have blurry. Right, okay. So figure 2 shows Kyle and Keon, right? Balanced on a seesaw. Kyle weighs 500 newtons and Keon 300. The seesaw is made of a uniform plank of weight 800 newtons, right? So the plank itself is weight 800 newtons, right? Which is 4 meters long, pivoted in the center. So how long is each side? 2 meters, right? So try this here now. By taking moments about pivot, calculate the distance that Keon must sit to balance up Kyle. I'm just moving up a little bit, right? Go ahead. Try that there. Again, to start it, what you should do is put a little diagram, right? Create a little diagram and then let's see if we can figure it out. Don't try to draw them on thing, right? Draw the plank, draw weight, one weight is for Keon, one weight is for Kyle. Okay? And try to find where you should sit. Yeah. Draw the system columns earlier. Some of you are drawing it like a way seen it there. Draw the system columns. Okay, fine. Other things about here, the way. What you got?
Join class. That's
That's my wife. Okay.
Oh. It's hybrid.
Huh?
Yeah.
Ready? So a diagram should have something like this. Right? They said Kyle's weight is 500, so Kyle on this side put 500. Keon's weight is 300. Right? The seesaw is made in a uniform slant, right? By taking moment. Almost does. And Kyle sits 1 meter away. So your diagram should look like that. Do you have that? Apply the movement. Quick, quick, quick. Apply the moments quickly and let's see what you got for X. Come on. So bad, huh? I know, but they're now.
That's funny.
Ready? So apply your movements left and right, and then see what you get online. You can message a value. Like when I pass it, right? Put your SI unit over it, and you have to put the SI units right. The length they want to put the SI unit, put the length. Yeah. Right, so when you apply your principle of movements, sum of the anti-clockwise is equal to sum of the clockwise. Which one anti-clockwise? Eon, right? So it will be 300 by X is equal to 500 by 1. So I got 300X is equal to 500. X is 500 over 300. So I got 1.67 meters. Next one. Still have more, right? So that's good enough. Still have more. Still have part 2 and 3. Right? What you might recognize is that two forces missing from that diagram. I join them in blue. Anybody can help me? What are the two forces? What are the two forces missing in the diagram? The weight that will act down the middle. What's the weight again? 800, and one more. The reaction force, right? Why is there a reaction force? Because the wood acting on pivots and the pivot acting back on the wood. So they want us to calculate R. 4 marks. Yeah. Calculate the reaction force and then tell them what's the moment of it. Right? Calculate the reaction force R and then tell them what moment it is. Planck itself have that.
What? So,
Yes. Right? How we going? Part 2. Upward equals to downward. Upward equals to downward. And upward downward forces. And then equal to the upward. So that'll be what? 3, 5, and 8. 100.
Oh.
Right. So R is equal to 300 plus 500 plus 800, right? Upward equals to downward. So the answer for part 2 will be 1600. Question: what is the moment of the reaction force about R? Sorry, about pivot. Where is the reaction force? The reaction force is on the pivot, right? So what will the moment be if something is on the pivot? 0. Answer is 0. Okay? Right? Answer is 0. What is the moment of the reaction force about the pivot? Answer will be, okay? Whenever you're on the pivot, you have no moment. That's okay?
Yeah, I realized I was in a class of it.
You can write it. What is the moment? What is the moment of the reaction?
Yeah. Okay, now let's see what it is.
Wait, then you don't have to write it down. What's the first? When you read the question, write down all the info, right? Let's go again. Let's go a little bit harder. Ready for this one, boy?
We do this. Oh, my God. We did this. You're like, this is stupid. Yeah. Oh my God.
Are you ready for this one time?
Yeah.
Alright. It's easy, but I'll give you an next one. Hold on. Still good question.
Shell next week. So.
We're gonna get more, we're gonna test something out. That's what we go for.
So we would be.
Right, take a little reach. You have a plank. And the person doing a balancing up, such a question. Right there.
You couldn't act if she.
Right, so here we have, they give you the diagram already, right? They give you the diagram. Because nobody inside, right? That's why it's magic. That's why it's magic. Nobody on the right side. One is 1 and 1.5. Right, so they want to label W. And when you label W, I'm moving down a little bit, right? They want you to calculate W. Right? Know your diagram, put in all your forces and apply your principle, right? Which side W? Which side the W is on? W on the right side, right? And your principle of movement. Right, right.
This week, right? Patricia, lecture. Patricia, and so it's not true.
No, but fellowship, I don't know. That's such a show on the pivot. All right. So let's see what you all came up with so far. Label W the point on figure 2 where the weight acts. So the weight acting right here. Yeah, everybody okay with that? That's where the weight acting. Remember, the only way that will be balanced, right, is that there's something acting on the right side, of course. So how do we find W? It's balanced, right? So we're going to apply what? We're going to apply principle of moments, right? So we're going to apply principle of moment. Sum of the anti-clockwise is equal to sum of the. Can you identify which are clockwise, which are anti-clockwise? Adrian? Which are clockwise then?
The shape,
Right? And which are anti-clockwise?
back down from this one.
Okay, very good. Work it out fast. Let's see what you got. Right, so that'll be, always make sure you're working in SI units. 5 by 1 plus 400 by 0.5 is equal to W by 0.5. I got 500 plus 200 is equal to 0.5 W. Right? So W is 700 over 0.5. I got 1400. Anybody got that? 1400? No? Solomon, follow what's going on? Sure. So you'll see how the balancing act will work. Because of how heavy the plank is, right? The moment that the plank producing, balancing of Patrick and Patricia. Okay, copy it down. There's more to it. What? Next part. Yeah. Yeah. Try this here. Zoom up a little bit. Fix the diagram now. Fix the diagram. Work out that. Right. With that change. Right, so number one, you must have a diagram. Number one, let's see if we can fix up the diagram now. So Patrick sits alone on the plank. Oh, yeah. How heavy is? 500.
Yeah.
Calculate where he would sit in order to maintain it, right? Here is 1400 still. And then we got 1400. How far away you was?
That one
0.5. Right, but we don't know where Patrick's sitting. You can't get wet. So, well, before you start, remember I told you all, when you're answering a question, it must be FSE. Formula, substitution, answer. So you write the formula. Sum of anticlockwise is equal to sum of clockwise right? What's the next step? Right, so the anti-clockwise is 500 by X. So I got 700 over 500. $1.4. Yeah, good. Let's go again. Going a little bit harder now. Huh? Yeah. Good. Read it. Right, so I want to come on to it. They put it here already, that's right. But I get to that. Right, for the ones that for the here, they could just take a break. Come right here. Oh. Okay. Well, I need to then. On the way, right. Ready? Let's go again. Time to do one with the hand. I'll be here by about half to two. Until about half past six. So, right out the road. Until 6. Tomorrow when? But what time? What is it? Not until. This one? For what time? What time? That's all. I hear. Yeah, I hear my. Here I have a what? Okay, all right. Right, ignore part 1 and 2. I didn't show you that as yet, right? So part B, I wanted to draw a diagram. Ignore 1 and 2. And then we had to find the forces. So on this diagram, you have forces P. What direction will T act in? The force at T. What direction will that force act in? Up or down? Up. And then you have a 6 Newton, you have a 3 Newton, right? Anybody can figure out where the pivot is? Pivot at T. T, very good. Pivot at T. And please recognize that your distances are in what? Centimeters. And it's supposed to be in what? Meters. One move, no, don't worry about that. Part 2 just explanation. Part 1 is what we're focused on. So draw back a diagram, putting all the forces or the distances. Okay. Yes, so So using the information, find the force provided by the meter P and then the upward force T. So the question did not tell you where is this pivot, right? Where would you take the pivot? At T. Right? Take the pivot at T. And then move out. So quick. So T is a downward force. T is downward, T is upward. I join it here, right? Because I mightn't fit it properly then. Right? You'll notice I am converting to meters one time. Right? How far 6 from pivot? 25, right? So I help you out with the diagram. So from pivot from T. Right? So what we gonna do here? First thing we gonna say, of course, is pivot at what? At T, right? Which ones are clockwise, which are anti-clockwise? This is your anti-clockwise and this is your clockwise. Get rid of all of that. Right? So anti-clockwise is P. How far is P from the pivot? P is 0.05. So I put in everything you needed, right? Clockwise will be what? 6 by 0.25 plus 3 by 0.4. You all recognize, right? By Sasha. You work on the whole thing already? Right, we'll come up with phone and finish in that part, right? You all recognize that by I forget what one. Right. You all recognize by choosing the pivot at T. T is nowhere here. All recognize that? So if I choose the pivot at P, P will be nowhere here. Right? Why? Because the moment of T will be 0. That's okay? So it's always good to choose the unknowns as the pivot. Now we can work this out, right? 0.05 P is equal to, how much is this when you add it up? Closing, when you add it up, 2.7. So P is equal to 2.7 over 0.05, which is 54 Newton. Lucas, you okay with that? Lucas, how will you help me in the next part? How are we going to find T? Remember your 2 rules, right? We already used the first rule. What you'll do now to find T? What are the 2 conditions for equilibrium? Clockwise equal to anti-clockwise and upward equal to. So which force is acting upward here? No, upward. T. T acting upward and then which was acting downward? P and 6 and 3. Okay? Upward equal to down. That's okay? So that'll be 54 plus 6 plus 3. That's okay? Now for the physics part ahead now. One more part now after. Now the maths part. I'll do the physics. And I'll play back there. Online, you'll follow went on. Online. So I drew my diagram, I apply the principle of movements, and then I apply upward equal to downward, right? Come on. Right, look up here. Right? I'll pick up the thing to help me, right? The drink is moved. The drink is moved along the tree, closer to the hand. So you see the container of water, then move it closer to the hand. Is the force P less, greater, or the same? Explain the answer. Think about it, right? They're moving the drink closer to the hand. Think about what will happen here. All right? Think about it. You want, you can take a ruler and bring something to it. You are then. Think about it, right? I can stand by the house. Oh Lord, I can't hear myself. So it's less than? Well, why? Why? So when you bring the drink closer, it's less, right? So what will change? Let me see who's thinking here. What will change here? This value, right? This value becomes smaller. So this value will become, so when you divide, this value will become smaller. All right? That's okay? So write this down. The value is less. You gotta stop going on. Happy, yeah? Can't squeeze in one more. The value for P is less because the value for P is less because the clockwise movement, the value for P is less because the clockwise movements are now smaller. The clockwise movements are smaller. Hence, the anti-clockwise movements will also be smaller. Hence, the anti-clockwise movements will also be smaller. Right? Making the value for P smaller, right? So if the anti-clockwise smaller, P will be smaller. What would happen to T? P smaller, so T will also be smaller. Smaller. Right here, we're not so much. One more and we're done, right? Last one and we're done. Right? You don't need to read this, right? I'm moving down, right? I'm moving down. Calculate Y and we're done. I done. Ah, this one tricky again. Taking the wheel, right? So you have to figure out which are clockwise and which are clockwise. Do it. X not there as yet, yeah? X into the second part. Do it with X. So it's an equilibrium, right? Question said take moment. So you have to figure out which is clockwise, which is anti-clockwise. Right? So W is what? Clockwise or anti-clockwise? W is what? Clockwise or anti-clockwise? And Y is also find the moment, make them equal. W W will turn clockwise. And Y will turn anti-clockwise. That is finding movement and it doesn't. W clockwise. How far is Y from the pivot? 6 plus 0.4, right? What? Yeah, what's up? Huh? W is 0.4. Oh, sorry. What for the what? How far is Y from how far is Y from the pivot? 0.6 plus 0.4. Now follow what kind of equation here? Where did I get 1 from? Right? You can look at Y, right? Y is 0.6 plus 0.4 away, which is 1 meter away. So Y is 1 meter away from here. And W is 0.4. W by 0.4, Y by 1. How do I find weight again? Weight is what? Mass multiplied by gravity. Right? Mass is 25, gravity is 10. I got 100. Alright, still have more to do, right, but barely here and explain to a couple. Right, so I'll put 2.82 for it to do. Alright, and then we'll try, we'll do that next week. Alright, so we'll stop there, right? Okay.